Previous video we learned that the distribution of a electron in the different orbit is called electronic configuration. Now let's see the electronic configuration of first 20 element. First is hydrogen. Hydrogen has only one electron, and according to the rule, first orbital, the capacity of first orbital is to occupy maximum 2 electron. Here hydrogen has only one electron, so it is occupied in the first orbital. So the electronic configuration is just 1. Now in case of helium, helium has 2 electron and the capacity of first orbit is to occupy the 2 electron. So both the electrons are occupied in the first orbit. So the electronic configuration of helium is 2. We already studied that the number of proton and the electrons are always same. So this is the nucleus. Okay, here 1 electron, 1 proton, here 2 electron, 2 proton. Now let's see lithium. Lithium has 3 electron. This is the nucleus of a lithium having 3 proton. Now the capacity of first orbit is to occupy 2 electrons. So out of 3, 2 electrons are occupied in the first orbit. Now remaining 1 electron is occupied by the second orbit. Okay, so the distribution is like 2 and 1. So electronic configuration is of a lithium is 2 1. Okay, now let's see about beryllium. Beryllium has 4 electron. There are 4 proton in the center, and out of 4, first orbit contain 2 electron. Remaining 2 electrons are occupied by the second orbit. Okay, now so the electronic configuration of beryllium is 2 2. Okay, now let's see about boron. Boron has 5 electron. There are 5 proton in the nucleus, and in the first orbit, out of 5, the 2 electrons in the first orbit and remaining 3 electron are occupied in the second orbit, 1 2 and 3 electron. Okay, now the maximum capacity of second orbit is 8 electron. So we can draw the 3 electrons in the second orbit. So the electronic configuration of boron is 2 and 3. Okay, now carbon has 6 electron. So there are 6 proton in the center. Out of 6, first orbit contain 2 electron. Remaining 4 electrons, they are in the 1 2 3 4. Okay, they are in the second orbit. So the electronic configuration of carbon is 2 4. Okay, now nitrogen has 7 electron. So 2 electrons in the first orbit, and in the second orbit remaining 5, 1 2 3 4 5. So the electronic configuration of a nitrogen is 2 5. Okay, now oxygen has 8 electron. Okay, and there are 8 proton in the nucleus. So in first orbit 2 electron, and in the second orbit how many electrons are remain? 6. 1 2 3 4 5 and 6. So the electronic configuration of oxygen is 2 6. Similarly, fluorine, first orbit there are 2 electron, 1 2, and in the second orbit remaining 7, 1 2 3 4 5 6 7. So the electronic configuration of fluorine is 2 7. Argon has 10 electron, so 10 proton. Out of 10, 2 electrons occupied by the first orbit, and remaining 8 electrons, 1 2 3 4 5 6 7 8. 8 electrons are occupied by the second orbit, so the electronic configuration is 2 8. Okay, so 2 8, so 10 electrons. Now sodium has 11 proton, so out of 11, first orbit occupied 2 electron, now remaining 9 electron. So the maximum capacity of a second orbit is to occupy 8 electron, so we cannot draw a 9 electron in the second orbit. So second orbit, out of 9, second orbit occupied 8 electron, 1 2 3 4 5 6 7 and 8, and remaining 1 electron is occupied by the third orbit. So third orbit contain only 1 electron. So what is the electronic configuration of sodium? First orbit contain 2 electron, 8 electrons occupied by the second orbit, and the third orbit contain only 1 electron. 2 electron occupied by the first, 8 by the second, and 1 by the third. So the electronic configuration of sodium is 2 8 1. Now let's see about the magnesium. 12 electron, 12 proton. So first orbit contain 2 electron, remaining 10. So the capacity of the second orbit is 8 electron. So out of 10, remaining 10, 8 occupied the second, 1 2 3 4 5 6 7 8, and the remaining 2 electrons are occupied by the third, 1 2. So the electronic configuration of a magnesium is 2 8 2. Okay. Now aluminium has 13 proton, 13 electron. Out of 13 electrons, 2 electrons are occupied by the first orbit, second orbit occupied 8 electron, 1 2 3 4 5 6 7 and 8, and remaining 3 electrons occupied by the third orbit, 1 2 3. So the electronic configuration of aluminium is 2 8 3. So you have to write remaining element, the configuration of remaining element by your own.